So what is synthetic division? In class, we talked about how to divide polynomials, and we did this by using long division. And it certainly was long. It was a lengthy process. Synthetic division is basically a shortcut for this same process. It's the same idea, it just has a lot less things to write down. So to describe how this works, what I'm going to do is first do this process by long division, and then use it to show how you can do synthetic division, which is a shorter process. To divide this, the way we did it was, we wrote down x minus 3, we put our division symbol here like this, and then we copied down the polynomial, 7x cubed minus 5x squared minus 63x plus 45. Step 1 for this process is, I want to cancel 7x cubed, and I have to multiply x by something to do that. The thing you would multiply by is 7x squared. I'm going to put that above where the x squareds are located, but here it is, 7x squared. When I multiply this to the x, you do get 7x cubed. But you also have to multiply this to this negative 3, and when you do, you get negative 21x squared. In the division algorithm, we actually have to subtract this away from these two terms, and I indicated that by changing the sign on these two terms. This really is going to be a negative 7x cubed, and this is a positive 21x. These cancel to 0. I won't write it. Here, negative 5 plus 21 is positive 16x squared. To continue in the process, you would bring down the negative 63x and repeat. I now want to cancel 16x squared. What do I multiply this thing by to do that? 16x. That will go above where the other x's are, so we get 16x. Okay, 16x times x does in fact give me 16x squared. That's good. But you also have to multiply the 16 to this negative 3, so you get a negative. 3 times 16 is 48x. Now I'm subtracting those two things. I'll indicate that by changing the sign, like this. And when I combine these, let's see, negative 63 plus 48 is negative 15x. And then I bring down the positive 45. And we are at our last step. Okay, I want to cancel this negative 15x. Therefore, I have to multiply this x by negative 15. Will this work out perfectly for this problem? Let's see. Negative 15 times x is, well, negative 15x. That's good. And then also negative 15 times a negative 3 is a positive 45. It turned out that this worked perfectly. When I subtract these, that's going to be a positive. This is going to be a negative. They all completely cancel. I want to write something down, so I'll put down 0. So this all means that when you divide x minus 3 into this polynomial, it actually factors it. You get 7x squared plus 16x minus 15 with a remainder of 0. So how could this process be made shorter? I mean, this is quite a bit of writing. One way to make it shorter is to just not write down any of the variables x, like none of them. A couple other things to point out are that the number that we put here is always going to be exactly the same as the number that we put here. I mean, there's no real thinking involved once you've done this a few times. Since this is a 7 and that's an x, well, this has to be a 7. Also, I'd like to do something so I don't have to put in this extra step of changing the signs every time. Like, it's a very confusing step in this process. I'd like to get rid of that too. Those three things are going to be how we set up something called synthetic division. Without further ado, let's try to figure this out. So I'm going to do that over here. Step 1. X minus 3 is the factor that we divided in. Instead of using this x minus 3, I'm going to use the 0 of this factor, and that is the number 3. So I'm not using x minus 3. I'm going to use the 0 of this thing, which is positive 3. By using the 0, it's going to avoid switching this sign thing that happens within this process. I'll put a box around this. The next thing is I want to somehow write down this polynomial. But what we're going to do is just write down the numbers and leave off all the x's. So by that I mean I'm going to put down the 7, the -5, the -63, and the 45. So I'm just copying these numbers down in order. So I know this is really referring to the x cubed part, this is the x squared part, this is the x part, and that's the constant. We don't really need the x's anymore. And then we'll draw a line down here like this. And the rest is just a procedure that will give us this polynomial up here. All right, so step 1. You take the 7, you immediately just write it here. So you just like bring the 7 and put it right here. That is, in this step, choosing 7x squared was the same thing as choosing this 7. Over here, it's just like, just put the 7 right here. The second step is to take this 7 and multiply it to the 3 and place that number here. Well, 7 times 3 is 21, and so I'll put 21 here like this. What does that step just correspond to? The thing that we just did corresponds to, well, you take the 7, you multiply it to this -3, and it's -21, but then we changed it to a +21. Over here, that was all done in one step. 7 times +3 is +21. There's no need to change a sign anymore. It's already set up as +21. You then add these two together, -5 plus 21. Okay, well, that's going to be 16. And then you just repeat this process until you get to the end. Notice that this 16 is exactly the same thing as this 16 here. So the next step is take this 16, multiply it to this 3. It's 48, and you put that number here. No change in the sign needed. Next, you can just add these together. -63 plus 48 is -15. And that's the same as the -15 that we got here. -15 times this +3 is a -45. Again, that is changing the sign automatically for us, but when you do 45 minus 45, you get 0. So how do you actually read the answer over here? So I'm just going to put this as a reference. This 7 referred to the x cubed. So I'll say this was the 7x cubed, this was the -5x squared, this was the -63x, and the last thing was just a constant. Down here, this is now the x squared, the x, the constant term, and the remainder, which is exactly what is sitting right here. So this is the 7x squared, this is the 16x, the 15 is the constant, and this thing is the remainder, which is in fact 0. So to get your final answer, the final answer is 7x squared plus 16x, and then minus 15. So you can use synthetic division in place of long division. So it's completely okay to use this. Anytime that it says use synthetic division, you can always do this process here. However, if you're comfortable with this, or this made sense, you can use this thing as well to get the same answer.